Hi YouTube, this is Alexander again. Today I have this device on the bench, which is a permanent isolation monitor, and this one is broken actually. It doesn't work. And this is the TR22A version, and the purpose of this thing is to measure leak current between earth and neutral, or earth and grounding, depending about the neutral or the earth point treatment you need on your industry installation. This device is quite old, and they are replaced by many recent ones, and they are not exactly like those ones now, but this kind of stuff costs very expensive. This one you can find it on eBay from $150 and until $700, which is very expensive. And I guess if you need this kind of device because your installation was dedicated on this kind of wiring, of course you need exactly the same, because you can have more expense if you need to make another device which is not the same as this one. This one is just very simple. If you have exactly the same on your installation, just disconnect to the first one, which is in trouble, and put the another. This is for the reason why you have sometimes to keep your eyes on the price of old equipment like that, because simply the price is very expensive, because sometimes you cannot do without that. Old equipment are very pricey for this reason. So if you are interested to know why this kind of device can have a failure, actually, it's because if you look behind this one, which has lose his cover, you can see here main entry. You have 400 entry, and those one where there is a residue of soldering is the 220 volt entry. And we are going to see now very quickly why this failure on this kind of device, because if you are interested to repair this one, you don't have to struggle a lot. You just have to put this name on the net, and you can find maybe some information about that. And what I guess here about the trouble coming from this one is maybe there was a mistake of the connection behind this device. And if you put 400 volts on the entry of 200, maybe it can cause some damage to the internal transformer, because this device uses a special transformer which is very classical. Why? Because this kind of transformer are able to make a very good galvanic separation between the internal circuitry of this one and the other circuit which are in monitoring process. And in this kind of device, you cannot replace some parts according to the transformer if you intend to replace it by AC/DC switching power supply. You absolutely need a galvanic transformer like that. And those kind of transformers are very difficult to replace in this kind of measurement, because you cannot have such kind of galvanic protection. So don't wait a little bit and see where the problem comes from, and just make some measurements. So here you will have the entry, and if you see here on the ohmmeter here, it will display something. You can see there is no current through the primary of the transformer. This is the 200 voltage, and if I do this, there is no continuity. This transformer is probably dead. So if you look on the sorry, if you look here on the soldering point here, you will see here the primary, and you see here the secondary. The secondary attacks dedicated bridge rectifier, some Zalai diode, some regulator. This is the high voltage regulator, and if you look this little capacitors, it's very impressive to see that the voltage is about 100 volts. So this device requires a very high voltage continuous current, of course, to work with this kind of measurement. So anyway, if we make some measurement on the transformer point, on the transformer point, you can see there is absolutely nothing on the primary, and this is main different primary because this device is accorded to work with classical voltage and high voltage. And if you look here, so we have here a continuity on the secondary of the transformer, which is very high actually. This is very high because simply this transformer is able to provide high voltage. You know what I mean by high voltage. All technicians know that high voltage is from 991, 98, 99 volt, etc. So you know what I mean. So this primary here is disrupted. We don't know if this is the coil which is broken or if there is a fuse inside. Absolutely don't know. But the main thing you need to know is if the rest of this device is still working. So to know that, you simply have to inject some voltage according so the voltage showed on the capacitors here. I'm not going to play with high voltage here. I'm just going to inject something like 50 volts and see if this device reacts. Okay, so here we have the 50 volts need for the experimentation, and just put the voltage on these capacitors, positive and negative. Those grips are very nice, and see if the device works with the voltage. Oula oula. Okay. I just try a repair. I hope, finger crossed, like we said in English. Inshallah. That push button here. The resistor value of the grounding. And if I put my finger on the lead output, you will find another result. As you can see, with my finger, I put my finger on the external leads for measurement, and you will have a different value. And this value can be settable for an alarm or something like that. Okay, so if you have this kind of device and you want to test it, be very careful with the color of the wire, because I made a big mistake. My negative and my positive are all black, and I did this mistake, and big smoke, and so if you want to repair a device like this, you can be sure that the problem comes from this transformer. Okay. Oh, this is the transformer, but I'm not going to purchase it because I'm not interested by repairing this stuff. This is just a video like that. Okay. It was Alexander again. See you soon.